integration by parts. So first thing is first, if you have an integral problem, like this one, integral of x cubed dx. The first thing is you need to check the basic integration rules. So the integral is x to the power 4 over 4 plus c. Problem solved. So you need to check the basic integration rules. Cosine x times e to the power sine x dx. We have cosine x times e to the power sine x, and this is not a basic integral because I have a product, cosine x, trigonometric function, and exponential function together. Try to use integration by substitution. Use substitution method. So use substitution method works like that. I will write this in terms of u. How to choose u here? Mostly it will be in the power, it will be the inside function, and so on. U is sine x here. If u is sine x, you will take the derivative of both sides. Du is equal to cosine x dx. Then this product, cosine x times dx, is here. I can write this integral in another form. Integral of e to the power u du. Now it becomes a basic integral. I know the integral of e to the power u. It's itself plus c. Translate u back to x. So it was sine x, e to the power sine x plus c. Problem solved. That's the second way, integration by substitution. So step 1, step 2. Now step 3. If your integral is x times e to the power of x. First step, this is not a basic integral. If it is only integral of e to the power of x, it will be easy. If it is only integral of x, it will be easy. But it's none of them. We have a product. So I cannot use basic integral. I mean, basic integration rules. Is it possible to use integration by substitution method? So we need to find u here. How to choose u? Let's take a look at the power. If u is x, now I'm trying. If u is x, du will be dx. So I cannot simplify it. I mean, I will write e to the power u, again u times du. Nothing will change. Unfortunately, integration by substitution here doesn't help us. I cannot use the second way. So I need to use another method here. So the name of the new method is integration by parts. Before solving this problem, I want to explain the proof of integration by parts. So integration by substitution, we were calling that method inverse chain rule. So integration by substitution is inverse chain rules. Inverse chain rules. So you know the chain rule in the derivative. So it's the inverse operation, integration by substitution. So for the new method, we will take a look at the differentiation rules. Do you remember the product rule? Now let me write the product rule here. F of x times g of x. I will take the derivative of this expression. So what was the derivative of this product? Do you remember the product? First one derivative times second one derivative times first one. So this is known as product rule. We did it before. Product rules. Now I will integrate both of the sides. When you take the integral of both sides, let me take the integral with respect to x, of course. Integral of this part, f of x times g of x derivative dx is equal to integral of, here we have a parenthesis f prime of x times g of x, g prime of x times f of x dx. So what is the integral of left-hand side? So this is the derivative. When you take the derivative, when you take the integral of this derivative, you will find the antiderivative. It will be itself, is it? So this integral and derivative, they will cancel each other. So the left-hand side will be equal to f of x times g of x, because integral is a reverse operation. You are taking the derivative of f of x times g of x. When you take the derivative of y prime or that product prime, then you will get itself. Left-hand side is okay. What about the right-hand side? Using the properties of integral, you may split this integral. We have the sum of two functions, f prime times g plus g prime times f. You may write in this form, integral of f prime of x x dx plus, I will write in this form, since the multiplication has commutative property, I can write f of x times g prime of x dx. Then I will take this one here, this one. I will leave this one alone. So I will take here I will write in this form, integral of f of x times g prime of dx is equal to f of x times g of x. We are subtracting this one, both of the sides, minus integral of f prime of x times g of x dx. So we will get this. This expression is known as integration by parts methods. I want to make it a little bit simple. How? I will use nicknames or parameters, u and v. So let's say this one is f of x term. I will call it, this one is, yes, this one is u, and the second one is dv. So I will write this result in terms of u and v. It becomes integral of u times dv is equal to f of x is u. What is g of x? When you take the integral of g prime of dx, it will be v. This is v. So it will be v minus integral of what is f prime? U prime. It will be u prime. But instead of u prime, I will write du. F of x times dx will be du. So it will be g of x is v du. If u is f of x, when you take the derivative of u, you will get f of x times dx. So this product will be f prime of x times dx will be du. Because of that, I wrote here du. Now this is the original formula. Integral of u dv is equal to u times v minus v times du. So this is known as integration by parts methods. Just in order to make it simple, I will call it f of x u function, but u and v, both of them are functions. Both of them are functions in terms of x, u and v. So I gave that name, f of x is u. If f of x is u, look at the right hand side here, du will be equal to f prime of x dx. And if v is g of x, let me write that part maybe. If v is g of x, when you take the derivative of v with respect to x, this one will be dx. G prime of x times dx will be dv. Look at the expression. So this expression is dv because of that one. G prime of x times dx is dv. G of x is v. F of x is u. I will start with the x times, where was our original question? Here, x times e to power of x. So this is the rule. The rule is here. We will use this rule. Now you will see. We have this problem, integral of x times e to power of x dx. I have this. And I want to take the integral of this function. The biggest problem is here, how to choose u. Which one is u here? X or e to power of x?
E to the power of x.
Now, this is a tough question, how to choose u. That is the problem. Step one, first thing is choose u so that's the first trick or hint. Choose u so that integral of v is possible. I mean, here, if you choose u, the remaining part, you will have another function, and you could take the integral of the second part. If you cannot take the integral of the second function, it will be wrong. You need to change u. You need to choose u with respect to the remaining part. You could take the integral of second part easily. Not only that part, and du dx. When you take the derivative of u, that function should be better or simpler. When you are choosing u, you need to check the both of the functions. There will be a product of two functions. The remaining part will be the second part. You need to take the integral of that part. If you could take the integral of the second part easily, it's okay. It seems okay. And when you take the derivative of u, it should be a simpler function. It should be better. If the u is x squared function, when you take the derivative of x squared, 2x. Oh, it's better. It seems okay because you got a better function. It was x squared, now 2x. It means, yes, it may be u. That's a good option. And there is one more thing. I think this one helped you a lot. There is a rule, I-late rule. I-late. Let me write I-late here. I-late rule. So what's the meaning of that? I-late means this I, it stands for inverse trigonometric function.
Yeah, inverse. Sorry.
Inverse trigonometric functions. L, what do you think? What's L? Logarithmic functions. Logarithmic functions. A, algebraic functions. Algebraic functions. T, trigonometric functions. Trig functions. E, exponents. Exponential functions. So let me write some examples here. When you say inverse trigonometric functions, so arc sine, arc cosine, arc tangent. So logarithmic functions, log, let's say 5x, ln x, and so on. Algebraic functions, x to power 5, x cubed, etc. Trigonometric functions, sine x, cosine x, and so on. Exponential functions, e to power of x, 3 to power of x, etc. It means this. You will check the product. For instance, you have x times e to power of x dx. This is our question. You will check the function. X, this is algebraic function. E to power of x, this is exponential function. Look at the list, I-late. Algebraic functions coming before the exponential function. It means it will be our first function. This one will be u. This one will be dv. Algebraic function comes first here. If you have x, ln x, dx function. So you have two functions here, algebraic and logarithmic. Which one is first? L. Logarithmic function comes before. So this one will be u. This one will be dv, v. You may determine like that. This I-late rule help you a lot. You may use this everywhere, and it's easy to remember. So I stands for inverse functions, trigonometric functions. L stands for logarithmic functions. A, algebraic functions. T, trigonometric functions. E, exponential functions. X times e to power x. Which one is u? We have two functions. This is algebraic function. This is exponential. So I-late.
X.
I-late. So A is here. Exponential is the last one.
So x is first then.
Yes, x is u. Now you need to write in this form. U is equal to x. Immediately take the derivative with respect to x. du will be equal to, when you take the derivative of both sides, du is equal to dx, because the derivative of x is 1 times dx. Okay. The remaining part will be dv. What is dv? If x is u, dv will be equal to e to power of x times dx. X is here u. All the other parts, remaining parts, e to power of x times dx is dv. How can I find v? Here, in this operation, we are using derivative rules, differentiate d. Here, you need to integrate. In order to find v, you need to take the integral of both sides. When you take the integral of dv, it will be equal to v. Integral of dv is v. You know that integral of dv is v plus c. No need to write c there. What about the integral of e to power of x dx? It's easy. What's the integral of e to power of x? You need to find the integral of e to power of x. It's a basic integral, e to power of x plus c. Just we will write e to power of x. Now I will apply the rule. Look at the rule. Integral of x times e to power dx is equal to u times dv. U times v. Where is u? U is x. Times. What is v? E to power of x. Minus, because of the formula, integral of v du. What is v? E to power of x. What is du? Du is equal to dx. Du is equal to dx. Now our integral becomes this. X times e to power of x. Same.
So ex.
Basic plus c. So this is our result. Integral of x times e to power x dx is this. When you take the derivative of this function, you will get x times e to power of x. So this rule is known as integration by parts.